All right, welcome back to linear algebra. Let's jump into Anki to begin with. If A is a square matrix and n is a non-negative integer, what does the symbol a to the n denote? A times a times a n times. But if I is 0, it equals the identity matrix. That's where I missed it. Is it true that the inverse of a equals 1 divided by a if a doesn't equal 0? No. Matrix division is not a defined operation. All right, so that's that. I'm going to grade what I did yesterday, and then I'll be back to recall how I did. All right, there's nothing to grade because I'm still working on this problem from yesterday, so I'm going to keep doing that. I'm trying to finish that today, so talk to you in a bit. All right, for that problem I couldn't figure out. I ultimately used Quizlet because I just don't want to keep spending more time. Now it seems obvious. The inverse of a product of matrices is equal to the inverse of the individual factors in reverse order. So if we have found that the inverse matrix and we found the product of elementary matrices that express it, well then what do? We find the inverse of that, and how do we do that? We find the inverse of each of them, but in reverse order. So that's what I was missing. And then for today, we ripped through a bunch of questions actually. Starting with this, y equals mx, or y equals f of x, I should say, equals mx plus b. They're asking is this a matrix transformation? And basically I checked additivity, ultimately finding that it fails the additivity property, so no, it is not a matrix transformation. All right. 27, this gave me something. Gave me a bunch of the standard basis, gave me a bunch of the images of the, what do you call them? Standard basis vectors? What number is this? Images of the standard basis vectors. Boom. So yeah, and then I found this by sticking them together, whatever you call that, partition. And then I've used this to find t of x was given. All right, 29. This was find, basically use matrix multiplication to find the reflection of -1, 2 over the x-axis. And I believe from thinking, I believe the matrix multiplication is going to be x times -y over -1, 2. Essentially meaning, you plug in, no, I don't think it actually is -y. I think these would be 1. What I meant is 1 and -1, I believe. 1 and -1. And that's going to be it for all these. I put x and y, z, but I really should have been doing 1s and -1s. So this is looking for 2 -5th onto the y-axis. So this should be 0, 1 instead of 0, y. There. To ultimately get 0, -5. This gives me 3 points, -2, 1, 3 onto the xy plane. And so again, I put all these as variables, but really they should be 1s and 0s or -1s for the most part. Bang. Get that. Also -2, 1, 0. Again, another point, but this one's rotated by 30 degrees about the origin. So this one, I believe this is the standard base, or this is the standard matrix that is given for rotating counterclockwise. Cosine, negative sine, sine, cosine, but I can't remember exactly. But now I'm finding cosine 30 is 1/2, sine 30 is radical 3 over 2, and so we're going to plug those in and then multiply it out, but really close on that problem. So that's it for today. Talk to you tomorrow. See you.